Okay, this video is a walkthrough of moving your design from EDA Playground to Vivado. All right, and so what we're going to do here is make sure we set up our directory structure for Vivado. So we open up the files on box that we have set up. This is going to be lab 3, so I'll make a new folder and have that set up. Okay, and it takes a while for Vivado to run, so let's go ahead and start to open that. And while that's waiting, I'd already opened the lab 3 work that we've done in EDA Playground. So if you recall, what we have set up is our design side on the right-hand panel. We did a test bench on the left-hand panel. And we set up the test bench in a couple of ways. We had, line by line changing of inputs where we controlled this delay parameter #5. We don't need that since we already set this up with a for loop that gives us all the elements of the truth table. So let me go ahead and delete that. But what I am going to keep is the system command monitor. And it turns out in Vivado you don't have to explicitly set up the capturing of variables for the waveform generating of a simulation. Okay, so I'm going to make those changes. And then what I'd like to be able to do is import this work that I have into Vivado. All right, and so what you can do is click on download files after run, and if I run this, you'll see things showing up. We see our truth table as we expected, and it says creating a result folder, results.zip. I can open that folder. I can select on these two files, Control-C to copy those. All right, and then I'm going to go to my quick access folders, lab 3. I'm going to create a folder where I can access these sources. I thought I'd do that. Oh, it's in the wrong directory. This shouldn't be that hard. Okay, and so I rename that to sources. And paste those files in. All right, so I have that set up. I can close this. I shouldn't need the EDA Playground anymore, so I'm going to close that window. All right, so we're going to create a new project. And next, let's put it in lab 3 location. Select lab 3, and you can call it whatever project name you want to call it. This time we do have sources, so I'm not selecting this do not specify. We're going to go ahead and put those in at this time. All right, and we can add these files. I look in lab 3 directory sources, and I can select these two files. So click next, next, and get to this next point. We can put in our basis 3 board. Click on the board tab. Click on the search window for basis 3. All right, so here we are, starting the project. Okay, so it's finally finished with that, and you can see that we have some, if you click on the design sources and the arrow down, if you click on the simulation sources arrow down, these showed up in both places, but the test bench is not a design source, so we can click on here and move that within Vivado just to make it a little more organized. Okay, so we have that. All right, so at this point we have everything in the project that we need to run a simulation. So I'm going to move this around where you can see it. Let's click on Run Simulation. Okay, and that finished running. We saw some waveforms appear and then they disappeared off our screen. We can click on this Untitled here to get the waveforms back. And a couple of things I wanted to review with you on this is, first of all, the scale of this is a little off. So if you hit the zoom fit, now I can see all the different waveforms on the scale. That makes some sense. All right, so I'm looking at the A-test register, and it's doing what I'm expecting. It starts out with zeros, goes up to a 1, does that for 4 clock periods. The second variable B, 2 clock periods down, 2 clock periods up, I say clock periods, they're not clock, there's not a clock yet. We haven't gotten to clocks. But you get what I'm saying. You're looking at time delays that we put into the test bench waveform, and you get all the different combinations of A, B, C, and D. Okay. Within Vivado, you have a little bit more power to manipulate this waveform. So, for example, I can select all these, right-click, and I can make a virtual bus, and sometimes that's useful. All right, so make a new virtual bus, and you see what it did is it collapsed things down into a vector. All right, so A was the most significant bit in the vector, and D was the least significant bit. And what we have now is we're counting through the input combinations. All right, the other thing, I start getting to 9, A, B, C. So this is displaying in hex. And so I can right-click again, and I can change that radix to unsigned decimal. And from there, what I'm doing is I'm walking through the min-terms of this logic function. And so we'd already had a truth table that you'd done in Lab 2. So the truth table was sum of min-terms 2, 3, 5, 7, 11, and 13. So that's a little more convenient way of looking at it. Okay, the other thing that I have to show you is that if you look in the TCL console, so if you watch videos on this, sometimes this is called the Tickle console. All right, so in the Tickle console, we had our simulation set up with a monitor command, so you can actually see the truth table showing up in this console as well. Okay, so that's running the simulations that you had created in EDA Playground, running that in Verilog. I want you to know how to do that. So the next thing we're trying to do here is we're trying to get our design moved to the target board. All right, and so what we'd done in our first lab was we took our logic design and we had a top-level module that let us hook it up to the Basis 3 board. So we'll need to create that. All right, so let's put add sources, and we're going to do a design file. All right, and create a file. We're going to call it Top Logic 1, and tell it to finish. All right, so we have some, a wizard here to help us set up inputs and outputs. And what we did know is when we used the board, we had switches in those row vector. So there were 16 switches, 15 down to 0. Then we also had outputs. The outputs we were using were the LEDs, and there's also 15 down to 0, 16 bits of LEDs. All right, so hit OK. And we see this is the top logic, and we need it to be in the top, so I'm going to right click here. How can I tell it's not the top? Well, this is in bold, so it's not the top. Top logic is not the top, so I right click here and I set it as the top because I need that to be the top in order to program the hardware. All right, so from there I can open up that editor. So I double click that. And you see the module template is set up, and I just need to instantiate my design and connect the switches and the LEDs according to how I want them. All right, so logic 1 was our module name. I can give this an abbreviated name. And I'm going to pass in all the variables by name. All right, so we know how that works. It's .a, and then I put parentheses, and inside the parentheses I put the switches that I want to connect. So I'm going to use switch 3 for A, and then for B, remember the dot for the name, and then put the parentheses, and inside the switch I want switch 2 dot C. Inside the parentheses goes switch 1 dot D switch 0. Those are square brackets for the notation on the individual bits of the switch vector. Then I have the output. The output is .f in our logic module. So that's connected to LED. You have a choice. I'm going to put it to LED 0. All right. And so then that's missing one parenthesis here where I need to close this bracket. All right. So, you can avoid errors if you try to watch what's happening with the within the development system. Like when I put this parentheses, this closed parentheses, it will jump back and you'll see that highlighted in blue where you have the matching closed. And so you can kind of keep track of whether things are matching so that you don't make mistakes. Like I'm seeing a mistake here. I forgot to put that closing square bracket. All right, so I'm worried about all these, whenever I have an open, do I have a corresponding close? All right, so it looks like, I think I have that right. And put semicolon there. All right, so that should connect everything. And so I can save that. And we've already done the simulation of the lower levels. So at this time, we're interested in synthesizing our design. And now that we finished our top level design, we just need to add the constraint files so that the pin numbers for the switches and the LEDs are known to the bottom. Okay, so we're going to hit plus, add constraint files, next, add files, and I'd already browsed that directory. So remember, we've probably already created a constraint file directory. We're going to need the LEDs and the switches. So I hold down the control button, choose both those. Go here so we can finish that. And so at this point, we do have the constraint files in place, added to the project, and now we can run the synthesis. Okay, so I hit run synthesis, and this takes a while, and pops up a window, you hit OK. Okay, and it finished the implementation, and I'm sorry, the initial synthesis. Now we run the implementation. And now we're ready to generate the bit stream. You notice it defaults into open implemented design, but we, in our workflow, we skip straight to generate the bit stream. Okay, and that finished, and at this point we can open the hardware manager and move through the normal programming of the device. Again, I'm running this from my Mac. It has a remote connection to a Windows machine. So I can't do that step and show you, but we did that in Lab 1. All right, so that wraps this up. Hopefully this worked without a hitch, and you're able to learn about how to incorporate an EDA playground workflow into a Vivado workflow.